Hello friends, in this class I shall be discussing oblique projectiles. That is, if a stone is projected at some angle other than in this direction, I mean vertically up or vertically down, it is called oblique projection. Hence it is called oblique projectile. So let us suppose this is our ground. From this point, a stone is projected in some direction other than vertical. So how does it proceed? We know it goes in the curved path and reaches back to ground. So it is something like this. Right? So here, let the velocity of projection initially be some u. Let it is projected at an angle theta. Now we are going to analyze different elements or parameters of this one. I mean, time taken, maximum height, maximum horizontal distance covered. All these things we are going to derive now from the simple our idea of previous knowledge, which is motion under gravity. You see, first, what is a force acting on the body? It is its weight mg in the downward direction. So what is the acceleration of the body? It is net force by mass, we know. So it is simply g downward. So this is the important part of this one. Acceleration of the body is always g downward. At any point it is g downward. So let us resolve the velocity along the acceleration and perpendicular to the acceleration. So in the horizontal direction, the component is u cos theta. In the vertical direction, where we have acceleration, it is u sin theta, right? Now you see, acceleration in x direction is equal to 0, right? Because acceleration is purely in the downward direction. I may call it is ay also. Acceleration is ay only. So ax is 0. This implies Vx is constant. Velocity in the x direction is constant. So now I can write Vx is nothing but Ux, which is u cos theta. So at any point, the velocity in the horizontal direction is u cos theta only. At the highest point, u cos theta. At any point, horizontal velocity is u cos theta. What about vertical component? Let us see. Initially, vertical component is u sin theta upward, you see. So if you project with a velocity u sin theta upward, what will happen? It will retard, reaches highest point, comes to rest, and returns back. So it will go up like this, and it comes back like this, is it not? Here the velocity is 0. It is under the acceleration g, downward. The same thing will happen to this u sin theta also. The vertical component of the projection, u sin theta, and this u sin theta will undergo same changes as time passes. You see, now I'm writing. How do you write vy value? It is uy plus ay into time. Uy value u sin theta. Ay value minus g, because velocity is upward, acceleration is downward, time is t. Right? So what is the time of ascent or time of descent? Time of ascent, I mean time from projection point some A to the highest point B. time of descent means B to C, landing point. Here I may write it is some A, it is some B, again it is some C, right? It is simply Uy by G, where Uy is U sin theta by G. So what is the total time of flight? Total time of flight is Ta plus Td, that is 2 into U sin theta by G. Right? Let us see a few more things. What is this maximum height raised? This maximum height and this maximum height are same. I told you this vertical direction, the motion is identical. So how do you find this maximum height when you project with some velocity? It is simply u square by 2g, that is uy square by 2g, where uy is u sin theta. So it is u square sin square theta by 2g. Now, what is this horizontal distance covered? We call it R, range, horizontal range. Range is nothing but in the horizontal direction velocity is constant, you see. So horizontal direction velocity ux into total time of travel t. Ux is u cos theta and time is here we have found 2u sin theta by g. So it becomes 2u square sin theta cos theta by g. So this will be equal to u square into 2 sin theta cos theta, I may write as sin 2 theta by g. Now, few conclusions about the range. You see, for a given speed, I mean when u is constant, if I am varying theta, when is the range maximum? When this quantity sin 2 theta is maximum, is it not? So I may write sin 2 theta maximum is equal to 1 when theta equal to 45 degrees, is it not? Theta 2 theta is 90 or theta equal 45 degrees. Therefore, R maximum is equal to u square in place of sin theta 1 by g for a given speed, right? Now one more thing, you see, range is given by u square or 2u square sin theta cos theta by g. In place of theta, if you substitute 90 minus theta, what do you get? 2 into u square sin 90 minus theta into cos 90 minus theta. This is the range for 90 minus theta I am writing, right? By g. So it is 2u square into sin 90 minus theta is cos 90 minus theta is sin theta by g. So is it same as this one or not? So this is same as R for theta. What is the meaning of this? You see, for a given speed, the range for the angle of projection theta and the range for the angle of projection 90 minus theta, they are same. This is 90 minus theta, but the speed of projection both cases is same, then range is same. Okay, so this is what we mean by R for 90 minus theta and R for theta are same. We shall discuss few more points, important points of this projectile in our next class. Thank you.